In the last video, we took a look at example number 3, where we saw that we had smokers in a room, and we thought about selecting them, pulling them out one at a time, and that allowed us to see how this multiplication law used this concept of conditional probabilities, because after one person was removed, something changed about the nature of the room, and so the probability on the second calculation had to change. Notably, it often had a different denominator. Now, what we can see is that this is a type of sampling. It's a way of collecting a sample of individuals, and we're going to give it a particular name. We'll call this sampling without replacing, or without replacement. Notice it's because this person that we select kind of ends up outside of the group and never actually gets returned back into the room. They never get returned back into the group to possibly be sampled for the second time. So we're going to distinguish between those two types of sampling ideas. That's what we have down here. Sampling without replacement says that once an individual was selected, they cannot be selected for a second time. So like they're taken out of the room and they're not replaced back into the population to be chosen again. However, if I sample with replacement, then once someone is selected, they are put back into the room, back into the population, and could be chosen again. Now, depending on which one of these I'm actually going to be working with, I can get different types of answers for my probability questions. And so it's important that I often think about which one of these I'm being told to work with. To help illustrate this, let's take a look down here at example number 4. Suppose a bin contains 10 chips. 5 are red, 2 are blue, and 3 are green. Well, let's go ahead and maybe just create a little picture over here on the side. So I'll call this my bin. I'm told that there are 3 green chips in it. So there's some green chips. We have 2 blue chips, and we have 5 red chips. 3, 4, 5. So these are some chips in a bin. Now, I want to know what is the probability that I select a red chip followed by a blue chip. Okay, well, that should be pretty easy. I want to do a red first, and then I want to do a blue. Notice again, I would know that this is a time to use multiplication law for 2 reasons. One, I'm talking about a sequence of events, so red chip happens first, a blue chip happens second. But also, I don't have a table of information anywhere to easily grab this and. So I'll go ahead and I'll use what the rule, or that multiplication law of probability states, which says, first think about the chances of just getting the red, then multiply by the chances of getting the blue, given that you already picked the red on your first pick. Okay, well, this again should be fairly simple and straightforward. Let's try this. First pick, I'm going to go to the bin and I'm going to pick out a red chip. Well, there are 10 chips to choose from. How many are red? Well, 5. So I'm going to have a 5 out of 10 chance of picking a red on my first selection. Now again, it can be helpful to try to think about what's going on here or change your illustration to reflect it. Notice, I'm going to go ahead and follow what the problem says here. I will pull 2 chips one at a time from the bin and place them on the table. So my first red chip had to come out and I placed it over here on the table. So now I'm going to go back to the bin and I'm going to select again. Notice I'm sampling right now without replacing. So now I can go ahead and see if I assume I already pulled out a red chip and it's sitting down here on the table, and now I want to try to pull a blue, I can ask, how many blue chips are there left in the bin? Well, 2. Out of how many total chips? Well, that's 9. And so this is going to leave me with a total fraction that I think comes out as 1/9, or 0.1111. Okay, so it's actually just that easy. But sometimes, again, the picture can help us to visualize what's going on. Let's take a look at part B and see how this is a bit different. I'm going to go ahead and replace my chip into the bin, so I start with the full bin. Let's see what we have here for part B. What is the probability that I select a red chip? Okay. And then I put the chip back in the bin, and then I select a blue chip. Okay, so this is a little bit different. Notice I can't really notate that in my probability notation, so I have to just change the way I'm going to think about what's happening. I'm still going to find the probability of pulling a red, and then I'll find the probability of pulling a blue, given that I pulled the red. Well, let's see. if I pull out a red chip, I still know that's got a 5 out of 10 chance. I'm going to imagine taking that red chip, pulling it outside, but then once it's outside, remember I'm told that I need to put it right back inside the bin. So I pull it out, I notice that it's red, and then I drop it right back into the bucket. Well, now I have to ask, what are the chances now that I pull a blue chip? Well, notice it's no longer going to be 2 out of 9 because how many chips are in the bin? There are still 10 chips. So this is actually going to turn into 1/10, or the decimal 0.10. So you can see here that when I replace an item back into the bin or back into the population to get sampled again, I will get different probabilities. All right, let's go through and take a look at a couple other examples here. What is the probability that exactly one of the chips you select is red? Notice I'm still being told that I have to pull 2 chips. And we're going to go back to this idea that we're pulling them one at a time and placing them on the table in front of us. Oops, kind of deleted my bin there. Let me reset that. There we go. Okay, so I'm going to be back to going ahead and actually pulling out 2 chips from the bin and leaving them on the table. But here's something that's kind of tricky. I want exactly one of the chips to be red. I'm actually going to go ahead here really quickly and think about what could actually happen in terms of a sample space, just so I can try to think through what I'm going to end up with. The question is ultimately going to be, how many red chips could I end up with? Well, let's think about what could actually happen. I could go to the bin, and I could end up selecting 2 red chips in a row, right? Like a red, and I could get 2 red chips. It's also possible that I could pull a red and then another color, like a green or a blue. Now, since I don't really care which one, I'm going to go ahead and say I pull something that's not red. That could happen. This would definitely then be a time when I would be I would be looking for it because I got 1 red chip. But notice, isn't it possible that I could have gotten a non-red chip first and then a red chip second? So actually here, there are 2 different ways that I can get 1 red chip. And I don't really care which one of those happens. I could also see that in my sample space, I could pull 2 chips that are not red and end up with 0 total red chips. Well, in this case, since I want the probability of exactly 1 red chip, I can see that I have the probability of getting a red and a not red, plus the probability of a not red and a red. I kind of have to find both of those probabilities. And notice that there's no really kind of shorter way to do this, because I kind of want 2 of the items out of the 4. So, I mean, I can't really take like a complement approach and make this problem shorter. But I can just compute each of these directly. Let's see what it would look like. I would want the probability of a red, and then probability of a not red, given that I pulled a red. That would be the multiplication law for the first question, or for the first probability. Over here, things just slightly reverse order. Well, I can go ahead and try to look at this and calculate each one of these individually. Let's take a look at the first probability. What are the chances that I pull a red chip out of the bin? Well, should be 5 out of 10. Okay, now I have to imagine that one of those red chips is sitting over here on the table. It got pulled out. And so now I'm going to ask the question, what are the chances that I pull something out of the bin that is not red? Right? Because that's really what I care about, just anything that's not a red. Well, that could easily be done by just saying, well, let's see, there are 3 greens and 2 blues, so there are 5 items that are not red out of the 9 items remaining. Boom, first probability completed. Let's take a look at the second scenario. What are the chances that I pull a not red chip out of the bin, given that the bin is starting completely full? Well, let's see, pulling a not red chip out of the bin, there are 5 not reds out of 10. Let's say for the sake of argument that I've pulled out one of these green chips. Okay, so maybe it's this green chip has been removed. Well, now I have to go back to the bin and say, given that one of the not reds is sitting on the outside, there should be 9 chips left, and I want to pull a red chip, 5 out of 9. Very interestingly, it seems that these are going to generate the exact same probability. That may not always be the case, but it seems to be the case here. If I was to go ahead and actually add both these things together, I think I end up with a decimal of 0.5556. There we go. I have myself an answer. Take a look then finally down here at part D, the last part of this question and the last part for this section. What is the probability that I get at least one of the chips selected green? Again, this is going to be a perfect time for me to go ahead and think again about a sample space like we did up above. But this time, I'm not interested in the number of red chips that I get, but the number of green chips. But notice that not a lot is going to change here. I could get 2 green chips. I could get a green and a not green, or the reverse order, and just end up with 1 green chip. Or it's possible that I get no green chips. From right here, can you see if you can actually pause the video and work through the rest of part D? This should be very similar to what we actually did at the end of example number 3 in the last video. Give it a shot. See what you might be able to come up with. Okay, well, hopefully you took some time to try to figure that out. Let's see what we got here. Notice that the only scenarios that I'm interested in here, if I want at least one of the chips to be green, would be these 3 scenarios. The one that I'm not interested in is this scenario. So again, I'm going to have 2 different ways to proceed. I can say the probability of getting at least 1 green chip would be the same as saying I want the probability of green and a green plus the probability of green and a not green plus the probability of not green and a green. But that's a lot of work. That again requires me to find all 3 of these probabilities. That could take a while. So I'm instead going to choose to take the complement approach, which would say, why don't I take all 100% and I'll chop off the only probability that I'm not interested in, which is a not green followed by another not green. Well, I can go ahead. This would say, what are the chances that you pull a not green? Notice this would be here on our first pick. And then I select another not green, given that I already selected one at the start. So here's where sometimes these little subscripts can help us think about what's happening first and second. Now here I think these numbers are pretty easy to grab. There were 3 green chips in the bin, so there are 7 chips in the bin that are not red, or not green, excuse me. So that's 7 out of 10 for my first probability. Now if I've already pulled one of those chips out, there should be 9 chips remaining. And if there were 7 original green chips, or non-greens, and I pulled one of them out, there should be 6 remaining. And so I end up with 1 minus 42 over 90, also known as 48 over 90, or if you just jumped right to the decimal, you end up with 0.5333. So these questions obviously take a little bit of practice. There's a little bit of a learning curve here when it comes to trying to deal with these problems of at least and at most and exactly 1. And so you should definitely make sure you spend some time going through the worksheet questions for this section so you can feel confident that you understand how to tackle questions like these. And of course, if you have any questions, please let me know.